Dr. Mirko Bordignon, the Group Manager of Fraunhofer IPA. He will be talking about ROS-I EU and ROSIN, Advancing Robotics Platform through private and public support. Mr. Bordignon, please.
You all hear me? Okay. That seems to work. All right, pleasure to be here. Third year in a row, so some of you might already know me. For the others, I might have to give a bit of an intro. Also, to remark the fact that the ROS Industrial Regional Consortia are all run by applied research, no-profit organizations. So Fraunhofer, like A-Star, like Southwest in the US, is such an organization. And we believe that to keep the organization vendor independent, hardware neutral, that's a pretty important thing to provide a sort of neutral governance. So, as for intro. Okay, is somebody advancing the slides for me? Because it seemed like it went without a click, or maybe it's just magic. Anyway, we are one of the institutes of the Fraunhofer Society, the one dealing with manufacturing, engineering, and automation. Robotics is part of our activities, based in Stuttgart, Germany. Pretty sizable organization, all in all. As some of you already know, we divide our activities between contract research and even just technical development. Private and public research as in at lower TRLs. And we also enjoy a bit of public funding, which keeps us, able to be taking risks, such as looking into some platforms or some initiatives at times when maybe they were not as popular. So we were happy to team up with Southwest and later with the A-Star in this ROS initiative, also thanks to public support, which we do recognize and are thankful for. We do a number of other things on top of robotics. As you can imagine, Germany, Industry 4.0, big topic, or Factory of the Future, as it's called here, Industrial Internet of Things. Anyway, cyber physical systems in production. Also some more process-related things, coating. In Stuttgart, there's a lot of automotive, so coating, especially in the automotive business, is very relevant. Factory planning, and so forth. And we do have a robot and assistive systems department, which has a number of groups dealing with all different topics, some which are more foundational technologies oriented, like software engineering, the group which I have the pleasure to lead. Some that are more into applications, from handling intralogistics, mobile and service. Actually, those names are outdated. I think now it's service robotics for healthcare and other environments that are not manufacturing, and service robotics in manufacturing. But what I'm very keen of is that in the Fraunhofer tradition of spinning off ventures from its institutions, we have a large number of them, but two recent ones that emerged from the organization are actually based on robots that largely make use of ROS infrastructure. The Carobot on the left that you might heard of, actually it was yesterday in one of the slides. We're very happy to hear it as let's see, as the archetype of a service robot. And a robot programming tool that is also addressing different robots thanks to ROS compatibility. Now, we recently took a step back inside my organization and thought, okay, intuitively ROS made sense for us. We've been doing it for basically 10 years now, among the early adopters in Europe, already using it for the Carobot 3, so the second last generation of our service robot. Then when Southwest started ROS Industrial, we partnered up pretty at the very beginning, I guess, thanks to an internship of some of our employees with Sean Edwards, and did some initial pilots. We started the consortium in 2014, but now again, taking a step back, we're like, how does that fit into the grand scheme of things? And interestingly, it does fit pretty well, especially in the mega trends, if you want. So these connected factories or cyber physical systems entering production is one of them. And how does that play into? So first, I have to see what is Industry 4.0. I guess everybody agrees on it being the integration of total manufacturing enterprise by using integrated system and data communications, right? But actually, it's not really this, because this is a kind of an 80s thing. I came to find out relatively to my surprise. So you always think about Industry 4.0, about connected objects in a manufacturing environment, but basically the connectedness, so that being information enabled, is a relatively old concept. That was, again, computer integrated manufacturing or Industry 3.0 perhaps. There's a very interesting study that I retrieved from last year, which shows activities in this domain, which were relatively sizable in the 80s, but the difference compared to today is that those were endeavors undertaken by very large organizations, typically in automotive, with lots of engineering efforts. Basically, they had no platforms, and there were a number of other, say, blocking factors that I now will highlight. So what's the story? Like, if you already had all this integration of devices that would talk to each other, what's the difference with the current transformation? Again, call it Industry 4.0, Industrial Internet of Things, Robot Revolution Initiative in Japan, Factories of the Future. Well, first of all, now technology for cyber-physical systems is accessible and widespread. And those two, that's an example that I like to make often. That's the same thing, right? Same company, the Apple Newton, the iPhone, 14 years apart. Sometimes the context and what is available makes or breaks a product and an idea, right? I was gifted last week this by a friend that I met at Automatica, and that's like an industrial Internet of Things development board, so the production thing is even smaller. That's slightly larger than a stamp. The production thing, like once you're done with your development, is much smaller than a stamp. And it's probably more powerful than that Newton with Wi-Fi and everything else at $20. So you really have the understanding, okay, maybe computer integrated manufacturing was a bit ahead of times, but now technology is there to do that. Second, again, we went from information-enabled system, yeah, you can network everything together, to information-driven systems. That's a testbed that we have, and it's one of the many examples that you can find around about a system in which you do machine learning on data that you do gather, thanks to this abundance of cyber-physical systems. You do data analytics on it, possibly as a service. A lot of IT companies are entering the robotics and automation market, and they want to offer this, sometimes cloud, sometimes on-premise services by stacking up on top of what you already have in terms of automation, and the results drive further the operations. They tweak, they optimize for X, be it time, efficiency, energy, whatever, right? So information is still in the loop, but instead of subsequently being acquired, then you close the loop. And last but not least, we now have not just those experiments made in-house by GM or Volkswagen or so forth, but you have reference architectures, typically from top-down, I would say, government or industrial initiatives. Reference architecture model, Industry 4.0, is one that you're quite familiar about, that go into great detail and saying, okay, at product, field device, control device, up to enterprise or connected world level, you have this segmentation of what you should do. And typically they come up, for Industry 4.0 it was the case a couple of years later with further recommendations about you should use this standard at this part of the stack, you should use this other standard at this other part of the stack. However, it's not enough typically. Design by committee standards, as they're also known, have some shortcomings. They're typically endorsed by organizations, so companies are pretty keen to jump on them, but they're not necessarily vetted by developers. They don't necessarily have developers' traction. It takes quite a few long cycles to get there. It's a laborious process of meetings and iterations. And sometimes they do anticipate long-term needs. They really anticipate for something that might happen 10 years from now, but they maybe lack short-term answers. Actually, when I do my reviews on standards mandated by a reference architecture model Industry 4.0 for joint control level of industrial manipulators, there is little to nothing, right? Rough consensus on running code, OSS-style standards and architecture are good complements. I wouldn't say they're alternatives, they're good complements. They do have developer traction as they emerge by developers interacting on actual code. They do come with something that works pretty soon, release early, release often. They tackle problems on a need basis, which sometimes is a bit more of an emergency mode, and it makes you backtrack on some previous decision, but they do get there something, get you something which you might need and that you don't get with design by committee architectures. So we posit that for Industry 4.0 like initiatives to succeed, we need a vendor-independent hardware-neutral machine layer on which to stack these other services, up to data analytics and so forth, and possibly by combining the best of those two worlds. So we are pretty busy working on the OPC-UA side of things, but also we're pretty busy on finding ways to combine it gracefully, I would say, with ROS Industrial kind of interfaces be it for 3D cameras or especially for industrial manipulators. And again, don't take only my word for it. So Henrik Christensen is famous also for his API economy kind of talks recently. Actually, last year at ICRA here in Singapore, I was happy to see in his final remark that in robotics there are a few standards, a few areas where standards are attempted, and it is the ROS Industrial as the very first one. And he also remarked that these kind of initiatives are still emerging and some sort of platformization is needed. So we'll be happy also to have Henrik speak at the ROSI conference this year, because all stakeholders need to hear that this is a much needed action. So one of the actions, talking of it, that we embarked on to move towards this vision is ROS Industrial, specifically the consortium in Europe. And we, again, in hindsight, or like when we started, we were basically knocking at doors. It's like, hey, we have this great thing, open source for robotics. Why aren't you doing it? Actually, you have to bootstrap initial acceptance with, for any platform, proprietary or open source. It's always a problem of, hey, if it was so great, why am I one of the first ones that would embark on it? So you need initial buy-in from actors in each stakeholders category. So we have a number of categories of stakeholders, end users, great advantages. End users would be free to lock in. Industrial OEMs wouldn't need to spend as many resources as they do today on software development costs, and would make their offering standards compliant, so much more appealing. Integrators would also reduce the software development cost and make their offering robot agnostic, right? Ideal world, perfect. There's a number of buts, though. So actually, those are the main ones that I want to focus your attention on. But interesting, it's sort of a deadlock problem. Like those stakeholders need hardware, real support to think that they can put it on the factory floor with some level of reliability and some level of at least not being left out in the cold. But those guys, before they come up with an offering, they also need market pool. So how do you solve this deadlock? Then you have other factors that maybe you can work on incrementally, that I highlighted in green. And why the two different colors? Well, it ends up that we use, let's say, ROS Industrial as the umbrella project with which we tackle OEM engagement and the customer pool of outreach. And we're pleased to have Rosin, that I'll talk about in a few minutes, as a EU project that is really tackling issues in software quality, that we had the problems into pooling the kind of resources and longer-term projects that were needed to do so. ROS skills, education ROS skills, and what we call user-driven software development, not much different from the FTP concept that you heard about yesterday. Now, we had some buy-in. No, again, it's the third year that I have the pleasure to be here. The consortium yesterday is 65 plus members. We are close to 30 in Europe, having one of those bilateral agreements or MOUs. So now we have to consolidate this buy-in. How we did that? So the last couple of years, we were pretty busy into running dissemination events, even on non-technical matters. Can you do that from a licensing, from a liability standpoint? So if you go to our website still, we try to put all the slides, especially from the ROS Industrial Conference there, as a reference for you. You can also point people to, okay, for safety, we had the certified safety machinery expert from IPA, Theo Jacobs, providing us references to the relevant norms and regulations for the licensing thing. Katarina Marake, qualified lawyer, talked about it, telling us the do's and don'ts. Beta testing ROS products. We had the pleasure to have one of them at our booth at Automatic, as you'll see soon, and serve as a gateway to the industrial community for their offerings. Okay, I sort of buy the idea that a ROS native robot can have a market. Can we, again, do a trial at your lab? Making end users aware of ROS and its capabilities. As a matter of fact, many end users are not, let's say, on ROS.org every day, right? They need to hear from somebody that maybe they work with for 20 years that there is this new thing, what it can do, what it cannot. Now I put between parentheses things that maybe now are under Rosin, so like training and in-house, and something that was not among the initial objectives, but we found out as enormous opportunities, or for sure it's very important. So raising awareness at public funding agencies. So there is such a thing as a platform for open source robotics. And when you fund effort in robotics and automation in Europe, you should strongly encourage the funded entities to build up on what is there to let the next round of projects increasingly go from there without reinventing this stack all the time. So some results is that we have new ROS-based robot arms developed in the region, some of which I would attribute rather directly to also our influence, because it was done by tutoring, by consultancies of Fraunhofer IPA, other North Industrial Europe member institutions. I had the pleasure also of seeing a robot driver being open sourced by the manufacturer, which made it internally, but was a bit skeptical about releasing it. What's the story about open source? So meeting with the decision maker, really dissecting all the concerns that they had. It's a dense one, by the way. ROS pilots for customers are building up. Here, a big challenge, I guess, for all of us is going public about them. Not all manufacturers or industrial players are keen on showing how their operations are run. Another good result that ROS skills are easily accessible. We have plenty of opportunities for training in Europe. Funding agencies are increasingly attentive. Now they understood that open source communities are a thing and that they have to be attentive to it. That's just a montage of some trade fairs that I had the pleasure to attend recently. And again, the fact that you see, actually that's a full-blown demo, but behind you had the full ROS branding. So those are robots that you buy it out of the box, come with ROS compatibility, big result. This was also is also an interesting demo that was at Automatica last week. It was more on the research pavilion. Typically, we try not to talk too much about research projects because they're great, but they would give this flavor of obviously researchy, kind of. But this is a good exception, as in, so first it won this competition, the European Robotics Challenges. It was a joint effort by the FSI, a member of North Industrial Europe, MRK Systems, and Opel, the automotive player. And actually this did run at the Opel plant with the full signature by their safety officer. And it controls the safety lasers from within ROS. So as we said since a few years, no problem if your software is buggy, because typically you have a safety net of electromechanical devices, those painted yellow, right? And this really exemplifies what we've been saying, and people not always bought the idea, but it's there. And actually, I put a short URL here for you to read the whole press release, and I asked the guys to do a full blog post, which should appear soon on rosindustrial.org. We also had our own booth. It was one of the 8 demonstrators at Fraunhofer IPA's booth. Great appreciation for my colleagues who worked hard to get scan and plan work on a new PLC robot, also beta testing the product. It was particularly important to be at Automatica. Those are stats taken from the last edition, so probably they are same ballpark or even better. So you have something around 50,000 visitors in the 4 days during which the fair runs, and of which 80% are classified to be decision makers. So being there and talk to each of them was really important to get the ROS-I word out, right? Finish up with ROS Industrial, then moving on to Rosin for the last part, the main outreach activities. We have our ROS-I conference, which typically is at the end of the year, December. This year will also be in December. We have 110 plus attendees. The plus is on whether considering speakers as part of the attendees or not over 3 days. We're, again, pretty keen on making proceedings, meaning the slides, public. So go to rosindustrial.org events. You see the past events, click in there, and now they're indexed. We had the first workshop at the end of May on various technical topics. Purpose was to make some of this development, bridging ROS and PLCs with codices or PCUAs and other efforts emerge. We'll have another one in the fall. We had this demo at IPA's booth with good feedback received. And the current focus, again, as I like to say, make existing development emerge. Typically, it's consists in me and being annoying enough with developers such that they do get to release what they feel is not good enough, right? But it's important to gather early users and gather feedback and to get these release early releases often. Now that you have the OEM with ROS support and you have end users being more sensitive for the neutral standards topic, ROS for system integrators is a big topic. an idea that we are considering for the full workshop is a step-by-step breakdown of a complex application. Could be scan and plan in a dedicated session, so they can really be shown how by taking these pieces of open source and putting them together, you can get there. Further engagement with OEM, we had the pleasure of having Universal Robots just joining the consortium. As some of you might know, there are a number of drivers out there for UR. Part of the engagement with them would be to collaborate on a single official endorsed driver. News coming later this year. Watch out for Roscon. Another thing that I noticed might need some work is repositioning ROS-I value proposition towards research members. Typically, those organizations are already ROS capable. We are developing a new model. As to them, the technical proposition is different than to commercial entities. And last but not least, ROSIN. What is ROSIN? That's the public action. And okay, I think I'm still doing good on time. What is it? So we made a pitch to the funding agency in 2016, together with TU Delft, longtime member of ROS-I consortium and other consortium members. And basically we told them, look, there is this beautiful concept in open source, sweat equity. Those who put the work have a say, right? So don't be stressed about this not being originally from the EU or maybe this going somewhere else. That's always been the case with open source. And instead of funding something else, just do your own thing, foster our role in ROS by putting a small portion of the enormous spending that we have in robotics, at least in civil robotics in Europe, right? Apparently we were successful because we acquired this project that is roughly an 8 million euros project running now it's a year and a half in. And again, the main takeaway points that the agency bought were, okay, you have to make ROS better, business friendlier, more accessible. And the extra goal was we had a lot of EU-based publicly funded activities and we tried to act as a concentrator. 6 partners. And what are we doing it? So we have key actions to make ROS better. Software quality is the first thing. Business friendlier. So we have this, actually almost half that money, 3.5 million, are for FTPs that we fund with a continuously running open call, and more accessible. So train more students. That's never been a problem. Students have been doing ROS in labs in some time. Professionals were a bit more of a problem, used to PLCs, Windows, etc. Actually, we also have an open call here to fund your education initiative. So, software quality efforts. We started with community engagement with a quality working group on a topic on ROS discourse. Actually, there's an interesting study that was the result of the first year of dissecting the dynamics of the ROS community. And this was also a prioritization of actions based on the feedback gauged on ROS discourse. It already resulted, actually, in the pipeline most released. So that's from the working group on work package free, so on software quality assurance. So first, there was the creation of this one-stop shop for anything related to quality. We have extended CI jobs, and now you have this nice badge starting from Melodic, so you can go and check it out yourself. For instance, this is taken from ActionLib, telling you how many tests are in there, when it broke, when it did fail. If you click, it will bring you to the failing test. We have an interesting concept, the time machine, to go back in time and recreate basically the environment when something maybe broke. You are testing a legacy component. And in the works, and I had those guys commit to give a live demo at the conference later in the year. We have history-based linting and fuzzing. Business friendlier, again, this call, going the last mile. Maybe you are a manufacturer of hardware. You need the hardware, the driver for your hardware to bring in the ROS ecosystem. These and many other type of activities, we fund them up to 1/3 of the cost through our open calls. Some results are already in there, like the Insenso cameras that you often see now. They have their own official driver. This is just the first batch. Now we have a second batch actually tomorrow. We have the time code to grant the third batch of calls. So now the first batch plus the second, we already had $500,000 of money that we've given away, which given that we fund only 33%, why? It needs to be relevant for you. You need to have some skin in the game, not keep just your developers busy, but do something that really relevant for you. We set in motion $1.5 million of development in 1.5 years. I think it's not bad, and it's once we give out all the 3.5 million, it will be 10 million of development that we set in motion. Last but not least, the training, so more session, more diversified. We have a summer school that has been running in Aachen for quite some time. Now we have Ross Industrial Academy with the extras, Bash and Python crash course, best practices from development to release, packetization, continuous integration, and so forth. We trained over 100 people in 2017. We trained more than 50 so far. Next session actually is on Monday in Stuttgart. We're sold out since quite some time, so a very good answer from industry. And we have a number of multipliers. We train instructors during those training sessions that then in turn go and train their people themselves. So actually this gentleman came last year and now at his maker space in Italy is running independently ROS courses. That's really a way to get local communities. And very nice as a multiplier as well, we have a MOOC starting September 5th on edX for free. If you want a verified certificate of attendance, I think it's $50. Hello real world with Ross. That's also a very nice way to multiply our efforts. And with this, I believe I'm done. There I am, fresher, younger, nicer. Here for your questions. Thank you.